Hello, ladies and gentlemen. Now we are going to do the second half of 5.5. We're going to talk about synthetic polynomial division. It is significantly easier than long division, but it does have some restrictions. So our objectives for the day are to review long division, do synthetic division, then we're going to use the division to factor a polynomial and then find some zeros. See if we can get us in focus. Okay, so let's review a long division problem first. So I want to divide 3x cubed minus 2x squared minus 61x minus 20 by x minus 5. I don't need any placeholders, so I'm just going to start my division. So I'm going to rewrite my problem. So there's 3x cubed minus 2x squared minus 61x minus 20. All right, now I think we're ready to start. So I'm going to divide 3x cubed by x, and I'm going to get 3x squared. And then I'm going to write that up top. I'm going to multiply through x minus 5 to get 3x cubed minus 15x squared. I'm going to write it down. Minus the 15x squared. Draw my line. The next step is to change the signs. So positive 15 and negative 2 is 13x squared minus 61x. Now I'm going to do 13x squared divided by x. Remember, it's always the very first term that's divided, not any of the other terms. Okay, so there's my 13x squared divided by x. I get 13x. I'm going to write it up top, and then I'm going to multiply through. And when I do that, I get 13x squared minus 65x. Sorry, mouth and hand weren't working. I'm going to write that down. So I get 13x squared minus 65x. Draw my line. Change the signs. 65 minus 61 is 4x minus 20. Okay. 4x divided by x is going to give me 4. Write it up top. Multiply through, and I get 4x minus 20. Write it down, and then draw my line, change signs, and I get 0. So the solution to this one is going to be 3x squared plus 13x, forgot my x up there, so sorry, and there's a 4, and then plus a remainder of 0. And then that would be my answer. So that was very nice. So now what we're going to do is a method called synthetic division. And actually we've already learned it. It was when we did synthetic substitution. So you've actually already done it. U-T-I-O-N, T-U-T, substitution. That is a long word. So we're going to do synthetic division, which is basically the same process as doing synthetic substitution. You only have one caveat, and that is that the divisor must be linear. And what that means is if I wanted to divide by x minus 5, that would be okay. Then I could do synthetic division. But if I wanted to divide by x squared minus 2x plus 3, I could not do synthetic division. I would have to actually do long division. So for synthetic division, you can only divide if the divisor is linear. Alrighty, so let's redo the problem that we did up above. I think I can scoot it down so you can see it. So remember, if you look up here, we had 3 cubed squared first 0, so I didn't need any placeholders. The other caveat about synthetic division is that you divide by the actual 0. Okay, so in the problem that we had up above, at the top of your page, we divided by the factor x minus 5. So remember, that means that the x-intercept is actually x is equal to 5. So I'm going to divide by 5, scoot it up a little bit so you can see, and then I'm going to write down my coefficients. So I had a 3, a -2, a -61, and a -20. And I know you can't see it on my page, but you should have it in your notes. So I draw my line for the synthetic division, bring down the first term. 5 times 3 is 15. 15 minus 2 is 13. 5 times 13 is 65. 65 minus 61 is 4. 5 times 4 is 20. And then when I subtract, I get 0. So if you'll remember, when we did synthetic substitution, we substituted a value in and then would look for this number. This number is actually the remainder. So that's kind of cool. All right, a couple of things to notice. We started with a third degree polynomial. The answer is always 1 degree back, so the answer would always be 1 degree less. So I usually write those numbers out on the side so that I can remember what I've done. So that means my answer then, if it's a second degree, this started as a third degree, is going to be 3x squared plus 13x plus 4. And I just go in descending order. This is the squared, first degree, 0 degree. And if you'll notice in your notes, since you can see both pieces, that's the answer that we got when we did it by doing long division. So I can always do a problem by synthetic and long, but I can't do synthetic division on every problem. So sometimes I have to be more careful. The criteria are that the divisor has to be linear to be able to do synthetic division. All right, so let's do a couple more examples. We actually have a fairly short video today, which is very nice. Okay, and we have a couple more examples for you, and then I'll give you your problems. All right, so let me make sure you can see the page. Here's your next example. We are going to divide x cubed plus 18x squared plus 95x plus 150. We're going to divide it by x plus 10. So I'm going to use synthetic substitution, or sorry, synthetic division, because my divisor is linear. Okay, if I look at my expression, I have third, second, first, 0, so I don't need any placeholders. So if the factor is x plus 10, that means that the 0 is a -10, and I'm going to divide a 1, 18, 95, 150. Whoops, got an extra 1 in there. Draw my line, bring down the first term. A -10 times 1 is a -10. 18 minus 10 is 8. A -10 times 8 is a -80. Add and I get a -15. A -10 and a -15 is, oops, positive 15, my bad. A -150, and then when I subtract I get 0. So that means that my remainder is 0. I started the problem with a third degree. That means I finished the problem with a second degree. So my solution is going to be 1x squared plus 8x plus 15, and that is my solution. So synthetic division is glorious, okay? All right, so now let's use our synthetic division for a different application. Get all those words in there. All right, so now I want to use my synthetic division to actually help me factor. Okay, and then I'm going to be given a function and a factor. Okay, so I'm going to be given a function and a factor, and I'm going to use synthetic division to help me find the rest of the factors. Okay. All right, so let's say I'm given a function, f of x is equal to x cubed plus 6x squared plus 5x minus 12, and I know that one of the factors is x plus 4. So I want to write what's called the linear factorization, which basically means I want to write my polynomial in factored form. And remember, since it's a third degree polynomial, I'm going to have 3 factors. So I'm going to start by using this factor, and I'm going to do synthetic division. So I'm going to divide by a -4. I don't need a placeholder, so I'm going to write a 1, a 6, a 5, and a -12. Okay. Bring down the first term, draw my line, and there, now we can start. A -4 times 1 is a -4. 6 minus 4 is 2. A -4 times 2 is a -8. Plus 5 is a -3. And a negative is a +12 and a 0. Remember, I started with third degree. My solution then is going to be a second degree. And I'm missing 2 factors, so this is where the other 2 live. So this is x squared plus 2x minus 3. I can factor that as x plus 3 and x minus 1. So now I know all 3 factors, and I could actually write what's called the linear factorization by writing down all the factors. There's the one that I was given, and here are the 2 that I found, oops, that's a 1, by doing my synthetic division. Okay, sorry, that's bad handwriting. That's a 1. So this is the linear factorization. Each one of these is a linear factor, meaning it's raised to a power of 1. And if I actually redistributed all of these things, I would get my original function. Alrighty, so we have a slightly different application of the same thing. Okay, so I'm going to draw us a little line, and now it's going to say it's going to be worded slightly differently. All right, so now you're going to be given the function and a 0, and you're going to be asked to find the missing zeros. So now let's talk about what that means. Okay, if I have, let's use this previous example, if I have a third degree polynomial, that means I have to have 3 zeros. Well, and notice what we found in the last problem. I had a 1, a -3, and a -4. So even though we wrote the linear factorization, I could then also use that to help me find the zeros. Okay, so now let's do an example. So I'm going to have f of x is equal to 4x cubed minus 25x squared minus 154x plus 40, and you're going to be given that one of the zeros is 10. So I'm going to do my synthetic division using the 10. I have a 3, a 2, a 1, and a 0, so I don't need any placeholders. See if I can squeeze it down here on the bottom. I have a 4, -25, -154, 40, and draw my line. Okay, bring down the 4. 4 times 10 is 40. Subtract 25 and I get 15. 15 times 10 is 150. Subtract and I get a -4. A -4 times 10 is a -40, and when I subtract I get 0. So another cool thing to notice, and it's happened in the last 3 problems, if you end up with a remainder of 0, that means that this is actually a 0. That also means, like if you had a graph that means that would be a place where the graph crossed the x-axis, meaning that it's a solution. Okay? This was a third degree polynomial. That means this is a second degree polynomial. Okay, so I'm left with 4x squared plus 15x minus 4. Well, I'm missing two zeros, so now I need to factor this expression. So I'm going to do the AC method. And I'm actually going to go to the next sheet of paper so that it doesn't get too crowded. And I'll rewrite that at the top of the page. So we had 4x squared plus 15x minus 4 left. And we're going to use the AC method to factor that. So I'm going to multiply my A and my C. So 4 times a negative 4 is a negative 16. And the factors of a negative 16 that add or subtract to give me 15 are going to be a positive 16 and a negative 1. All right, so I'm going to rewrite. So I get 4x squared plus 16x plus a negative 1x minus 4. I'm going to group and group. In the first two, I'm going to take out a 4x, and I'm going to be left with x plus 4. In the second one, I'm going to take out a negative 1, and I'm going to get x plus 4. Now they have an x plus 4 in common, and when I factor it out, I get 4x minus 1. So my zeros are going to be x is equal to a negative 4, a positive 1/4, and then the 10 that they gave you in the original problem. So we had a third degree polynomial, and now we have found all three zeros. So that's actually kind of cool. Alrighty, now we're done. I'm just going to give you your problems. So actually a much easier day than when we talked about long division. For the first one, I want you to divide using long division. Just need to keep practicing that. Alright, you're going to have x to the 4th minus 5x squared plus 8x minus 2, and you're going to divide by x plus 3. Your second problem, scoot these up so you can see, you're going to divide using synthetic division. Okay, and that one's going to be x cubed minus 4x plus 6 divided by x plus 3. Don't forget your placeholders, otherwise your answer will be incorrect. Number 3, you're going to be given f of x and a factor. So I want you to write the linear factorization. All right, you're going to be given f of x is equal to 3x to the 3rd minus 2x squared minus 61x minus 20. And your factor is x minus 5. And then one more problem, number 4. You're going to be given f of x and, it's an and, a 0. And I want you to find the missing zeros. Okay, make sure that you list your answers when you're done. And f of x is going to equal 3x cubed plus 34x squared plus 72x minus 64. And you're going to be given x is equal to a negative 4. Alrighty, those are your problems. Good luck, and I will see you tomorrow.